Hello and welcome to my second video on string manipulation. If you saw the first one, it was a pretty long and basic demonstration. It had some serious limitations. For example, it had to have exactly 4 words in 3 spaces. But in this particular case, I'm going to make it much more real world. All right, it's going to be able to take a sentence of any length with any number of spaces and automatically parse that into the individual words, and then save that into a special kind of variable called an array. Now, for my students, many of them haven't been exposed to arrays yet, but you really shouldn't. They're nothing to be afraid of. They're pretty fun and easy to use once you get the hang of them, and really powerful for large data sets. So I've actually created one right here. You can tell it's an array because I've got these square braces holding a number. This number is going to be the number of elements that I can put into this array, and I call this array my words, and it's going to hold all the individual parsed words out of the sentence once we feed it in. And of course they're going to be strings. I also started here with a variable called words. This is going to be the variable that's going to hold the initial input string. The number is going to hold the total number of characters, including dead spaces, that are within that string. And the counter is going to hold the number of spaces that ultimately gets detected when we parse the string. It's also going to be really handy because it allows us to more easily calculate index, as you'll see when we get down to the bottom of the code. So let's run it once. And actually, I'm just going to grab something from Science Daily. Let's see. Why don't we take like this sentence right here. Let's go grab that. Okay, so we grabbed a relatively long random sentence, and I'll put it in here, and once again I'll throw in some leading spaces and trailing spaces. We're going to clean this sentence up. Let's load it up. So here's the input sentence initially, okay, including the awkward spaces. The first thing it's going to do is trim it so that it fits nicely within the quotes, so we've gotten rid of any unnecessary junk. It converts it all to uppercase, which is going to be handy for when we're searching it. It now calculated the total number of characters, which was 113. Let's see if I can come back to that. Where's it at? 113. Oh, it keeps going so quick. Let's scroll back up. 113 characters. All right. It then figured out how many spaces there are. There are 14 spaces. That implies that there are 15 words. And last but not least, it went ahead and parsed it into the individual words and gave us the index positions of each of those words within the variable. Okay? So, how this works. Let's get rid of this, and let's take a look at the code. This, of course, is going to be, the loop is going to be those individual steps called, and each one is going to be its own individual function. And the dramatic pause is literally that. It's unnecessary. It was just there to slow it down so that I had a chance to read it, even though I still didn't keep up with it like I wanted to. And all it did was print 10 of these stars and then go to a new line every half a second. So that was a dramatic pause. The grab string function uses the read string function, which is included in the skiff, to gather what you type into the text and put it into a variable. That was the variable we created in the globals. Read string, in this case, I've actually included the skiff on this sketch, and you can see it down here. And you can see that it gathers data from that window. The next thing is trim it. This is a built-in function in Arduino, and literally that was what got rid of the leading spaces and trailing spaces, so it fit nice and tight into the quotes. ToUp also used a built-in function, okay, the to uppercase, and it converted every character in the variable words that we captured into uppercase. It does it automatically, really smooth and easy. Length. Alright, so we've trimmed it down. Now it was a matter of figuring out exactly how long it is. That's going to be important when we run our loop to parse it. And that is a built-in function in Arduino. It's simply called length. And so I'm calculating the total length of the variable words, and I'm going to put that into the number variable that I created in globals. How many spaces? Okay, and then again, this is going to be a handy thing to know when it comes time to figure out the index position. It can be sometimes hard to calculate the total number of elements within an array, so it's nice to know before you load the array how many elements there are. And we're going to use this how many spaces to do that. And what we'll do is we're going to look at the total number, or all the characters one by one, okay? And we're looking for a particular character. The character we're looking for is the dead space character, and we're going to be looking at it at this position. So it's going to take this long string, and it's going to start at position 0, and 1, 2, 3, 4, 5, 6, 7. And if it finds a dead space, it's going to increment the counter, which was initiated at 0. Okay? So every dead space it finds, it counts. You know, that would be 1, that would be 2, that would be 3, that would be 4. And ultimately we're going to know how many dead spaces are in this long string by querying the entire string character by character and looking for the dead space. It then displays it, and calculating out the number of words is just adding 1 to that the value of the number of spaces. Catchwords is the main portion of this, and I create some local variables here. So what we want to be able to do is there is a function built in called substring. Okay? And substring takes a string and breaks it into smaller bits. All we have to tell it is where to start and where to end. All right? Well, we now know that if I'm looking along character by character by character by character, if I get to a dead space, okay, which is what this is looking for right here, I know that everything in front of it is, especially in this first one, is going to be a new word. So ultimately what I want to do is save that into a substring. And then I want to look character, 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 character until I find this one. And then I want to go back to here, okay, and then record everything in this one into a new substring. So each time it's parsing this, it's grabbing it, and then it's going ahead and put it into a location in the array. So what we see here is the variables that I use to create it. Of course, I is just going to be a counter, and I actually decided to make it fit within this entire function so I can reuse it a couple of times. The end, the word end and the word start is going to be this location here, the end and the start of each individual word. And the word index, all right, is going to be the number that increments that tells us the location in the array that the word is actually stored. So for example, scientist is going to be put into index position 0. All right, it's the very first one. Exploring is going to go into index position 1. And at 2, we're going to have Mars. So this is 0, 1, 2. So that's the word index position. This my words, okay, is that array. And this, of course, is the string that we're starting with. Now, I played a little game here. I actually started it at -1 because what I want to do is it finds the location of this dead space. But I actually want to start here, okay? So you'll notice that routinely what it does is it calculates the start as the start plus 1, all right? So I started at -1. That's how I initiate it, which means I'm actually starting back here, but then I want to go +1, so I start with the S, and then I go to the end, all right? End is that first dead space. So now what I have to do is I have to get the next word. I simply make the start equal to the end. So on the next word, I want to start where the last one ended, which is here, but then I want to add 1 to it because I actually want to start on the E, so I add 1 to it, and I work my way to the end. All right, and I save that into a new substring. And then the process repeats over and over every time it finds one of these things. So now this becomes the new start, this becomes the new end. I start, I move it to the M with a +1, and I go to the end, and I save that into a substring. Now moving along, this is doing nothing more than calling those up one by one, and this is where it was nice to know that number of spaces, because now I know exactly how many times I have to call this loop. I have to run this loop to be able to get the number of the words out one by one, because my counter is going to be equal to those number of spaces. So now I know that I have to be able to gather this, X number of times depending on the number of spaces. So hopefully that was useful, and hopefully you can use this material, and I will see you again soon.